This is a short video on how to use our Jupyter notebook that enables you to import transient recharge from MIKE SHE into your MODFLOW model. We have two Jupyter notebooks, one for MODFLOW 2005 and one for MODFLOW 6. So you have here your working directory. I have here an exemplary model, my MODFLOW model. I will later, after I show you the workflow directly, in case you have already a recharge ready, how to use it. And once this is done, I will quickly show you how you can set up a very small and very easy MIKE SHE model yourself to try to test this converter as quickly as possible. So the first thing you should do is we need to create a virtual environment. I assume Python is already installed. If not, you should see where you found this video another shortcut or link to a video where I show you in 10 minutes how to install Visual Studio Code, Python, and UV. Now in this case, I go in here, copy the path, go to my command prompt. I click CD at the path to go into this directory. I type UV and then it will create me here a virtual environment. Now you need to know what you need. Then we need to activate this environment. It tells you here how to do that. Now it's activated. You can see this with the round brackets here. And now we need to install the missing packages. I now, for the sake of simplicity, open it quickly here in the text book. Here we are. You need to UV pip install. I think there in the other row are some of the missing. It doesn't matter if you type them in twice. Click enter. Now it's installing. I will press now pause because this can take a couple of minutes and I will resume when this is done. Okay, it's done. So our virtual environment in this working folder is now created. Now the easiest way to let Visual Studio Code recognize your working folder and your newly created virtual environment is to open a folder. I directly the path in here. Go one folder up. Take this one, select folder. Yes. Now it's opening a new session and I'm directly in the correct working folder. You see already, I already copied here the DFS2 output into this working folder. Now, in this case, my example is a MODFLOW 2005 model. I open this Jupyter notebook. Before I start, I need to select here a camel. I see here already suggested. This is the easy thing. This is example 3, camel. And now we should be ready to go. I directly jump to the bottom. Oh yeah, it needs to install IPyCattle and pip package. That's fine for me. I see here at the bottom still the old example from a previous example. Let's clear all outputs. Yeah, okay. Then I go to the very beginning. Now this installation can take a little bit. I make again a short pause and resume the recording in a couple of minutes. Now it is, the other packages are installed. Now I see here the timer is running. It's now importing the installed packages from the virtual environment. This can take also again a couple of minutes. And make a short pause. And it's done, 1 minute 26. Now it's running through. Okay, it has already an error. I did not copy the whole model from the previous folder, so let's try it again. Now it's working. Now it's inspecting the grid, and you can go basically through all the cells, recognizing the stress periods. In this case, it's a transient model. So I run all. You need to specify the correct recharge path. Oh, that one. No, this one is actually wrong because I'm using here right now a different file. So I replace here the name. Then it should work. Yes. Run all. Go to the bottom. And yes, we have it. Here's the new output. It's quite plain, but here you can see on the left side now the mean DFS2 recharge averaged for the whole period, and on the right side how it looks on the MODFLOW grid, which is not perfectly aligned. Let's go quickly through the script. So as you see, here's the standard beginning of a script, how what to import. Here you need to specify the folder to the MODFLOW model and the name of the num file. You need to define the correct EPSG code for the geographical reference and directly create here an output name for the shapefile, which you basically can directly reuse in order to create an example model, which I will show you in a couple of minutes. And then it's basically up to you to go through this Jupyter notebook if you want in detail. If you have problems with this Jupyter notebook, please reach out to me, phhu@dhigroup.com. I'm happy to support you if you run into issues. We tested this now on a couple of examples, but for sure there will be some exceptions that are not yet perfectly captured by the script. So if you test the script and download it and you run into issues, please reach out to me directly and we can solve it together. Here it creates you a short snapshot of how the MODFLOW grid looks. Then it writes you the shapefile, which you need in order to create a MIKE SHE model domain. It also creates you directly a geopackage file if you do it in QGIS, how we suggested. You also need here the information of the EPSG grid and give here the path of the DFS2. From there, it should run more or less itself. And you need to here modify the start time of your model. And the rest is a little bit up to you if you want to modify it, but from there it should go itself quite good. Now let's assume you do not have a recharge model right now. What you can do is you download MIKE SHE. You can even use it directly from our download from our dhigroup.com website page without a license, so no costs are affected, because you can start and run demo, my new MIKE SHE model, a small one, a very simple one, with the demo within the demo restrictions, just to test the workflow on your end. Now in this case, you can, as I said, I will provide you with this folder also. So MIKE SHE folder where there are some dummy inputs, and here an empty folder where I will store my SHE file. If you follow the other webinars, we recommend always to name the model just model. This will make the automatization of some post-processing more easy. We save this one. I select here a model domain defined by shapefile. I use actually exactly the raw output that the script gave me. Now in this case, you need to stay within the restrictions of, you see now here the model domain, the restrictions of the demo license, which would, I think, require here 2 meters. Let's try this one. I think it must be you can find them here in our online manual. If you Google MIKE SHE online manual demo restrictions, or at least if you found this one, you can type in here demo. You see here the demo limits, number of cells in XY direction 70, not more than 2000 cells, and so on. But we can stay easily within that, like that. Now in this case, the origin needs to, of course, match your MODFLOW origin. This is up to you. And the rest, for the moment, you can leave as default. I think we don't need to include overland flow. We deactivate the 3D groundwater module. Then we only need to provide MIKE SHE with a constant depth to the groundwater, relative or in absolute values. In this case, I leave it to relative. But in order to see at least any dynamics, I will change this to time varying. Go here into the dummy inputs under climate, and take the precipitation DFS0 time series. I choose here a time varying reference evapotranspiration, which is one folder up in the corresponding folder. I can see that here, and the rest we can leave here as it is. For the moment, we go for the simple two-layer Richards, or sorry, not Richards, the two-layer method, which is the more empirical one, but more computational efficient one. And then we are ready to go. I just adapt now the simulation period to my MODFLOW model. 1st of July to 1st of August. We should check that the total recharge to saturated zone is checked, this output. Then it creates the recharge file. And in order to see directly some time series, we create here 3 time series, which is always quite easy to do. TP for evapotranspiration, actual evapotranspiration, and recharge. We define here the atom type. I choose here coordinates in the middle of my model. Paste the coordinates here and make them in one plot. This is now a very simple model running only for 1 month. It's very fast, of course. So this is really just a quick start if you want to test the workflow on your end. Of course, these are not realistic results, but this is the easiest way to very quickly inspect to get a MIKE SHE model running. You see here in black the precipitation, in red the actual evapotranspiration, and in green the simulated recharge here. Now what you could do, you go to your MIKE SHE folder, next to the created model file, to the result files, you paste this DFS2 to the folder, I delete this one here, paste it, double click. Since the raw output from MIKE SHE will always contain several items and we need only one, it's the same workflow, a little bit like for FloPy. I delete here the other ones because in the Jupyter notebook, the item number is defined as 0, which then will take the first one. Check here the time steps. Yes, here is something happening. It's good. You could avoid deleting the 3 items by changing the item number of the DFS2 grid somewhere. I think it is somewhere here, the DFS2 item. 0 is 1. If you don't delete the other 3, you need to type in here 3, 0, since it counts from 0. So 0, 1, 2, 3 would be the 4th item. That's it. Have fun.